This is 10-5 study guide page 1, exercise number 4. This one they give us the vertices and the asymptotes of a hyperbola, and they ask us to find the equation. So I'll start out by looking at the vertices here, making a quick little sketch. So -8, 0 and 8, 0 tell me again that this is a sideways opening hyperbola, so I know that x is going to come first in the equation. It's not shifted up or down at all, and it's centered right around the origin, so I know that it's going to have x squared over something first, then y squared over something second equals 1. The distance from center to vertex is 8, so I know that this bottom here has got to be a 64. I know that distance there is 8. Now the y distance I'm not sure about, okay? So let's just call that b for now. The conjugate radius would be b. Not sure about that one, but I got to use this idea here that the slope of that line is somehow 1 over 6, okay? That slope is supposed to be somehow 1 over 6, and now that's going to be something like b over 8, because it's rise over run, and the run is 8, the rise we don't know is b. So I can kind of think about this as saying 1 over 6 is equal to b over 8, and I can try to figure out what b has to be in order to make that work. It looks like it's probably going to be some sort of a decimal fraction. This is a fraction equals a fraction, so thinking back to chapter 8, we can do the cross product here. So 1 times 8 is 8, and 6 times b would be 6b. Dividing by 6 on both sides gives us 8 over 6 equals b. They're both even, so you can cancel out a 2 from each. So 8 would become a 4, and 6 would become a 3. So this would be 4/3, which is about 1.3. And then you could square that to figure out what the bottom is. And squaring 4/3 would give me 16 over 9. It's a little bit less than 2. So I know it's going to look kind of weird, but this fraction is actually going to have a fraction in the bottom here. It'll have a 16 over 9 as this denominator. Okay, most of them won't turn out that way, and you'll be able to just look at the slope and figure out what that conjugate radius should be.